Okay, this is a follow-up video to help you understand how you use the ratios of similar solids when you're solving problems. So, if you understand the basic concept, you can go ahead and try working through these problems and then check your answer. I'm going to talk you through them. In the first example, we're given a scale factor with the information the base edges are 4 inches and 6 inches in my similar pyramids. So I'm going to go ahead and write a little note over here that my scale factor measurement is 4 to 6. And while we're at it, we should probably go ahead and reduce that. That usually helps us out and just makes things simpler. So I'm going to go ahead and rewrite that as 2 to 3 for my scale factor measurement. If the volume of the smaller pyramid is 189 cubic inches, find the volume of the larger pyramid. So I'm trying to get to volume, so I'm automatically going to go ahead and jot down over here what my volume ratio would be if my scale factor is 2 to 3 and I know that they are similar to each other. So I'm remembering from the chart and the concept of similar solids that we're going to take our scale factor measurements and we're going to cube them. So my volume ratio is going to be 2 cubed, my pen doesn't want to write, 2 cubed to 3 cubed, and if we go ahead and get numbers for that, 2 times 2 times 2 is going to be 8, 3 cubed is 27. Okay, we're going to use this number in a second, or this ratio I should say. I just kind of like to do the preliminary work, and the other way you can do it is sort of set up the proportion and then fill it in. Okay, at this point I am ready to set up my proportion. I'm going to look at my given information. I know that the volume of the smaller pyramid is 189 cubic inches. So I've got a volume measurement here. And I'm looking for a volume of the larger pyramid. So I'm going to put a V, or you can use X for your unknown volume. And the key is that you put the ratio that you put on the other side has to be the ratio of volumes, not the ratio of areas, not the ratio of bases, and therefore my 8 and my 27 is going to fill in that other ratio. Okay, if you put 2 to 3 there, that's going to give you the wrong answer, even if you correctly solve the proportion. At this point, I'm going to fly through the rest of it because you guys know what you're doing. We're going to get 8V equal to 189 times 27. I'm coming out with 5,103 for that. Dividing by 8. Volume is going to be a decimal. You're going to think you're wrong. 637.875. And we're talking cubic inches. That would be my final answer. Okay, that's probably the easiest example. Let's walk through another one. There might be one more element of difficulty in this. We've got similar cones this time, and this time I'm telling you the volumes. So I'm going to go and just jot down my information, volume measurements. There they are, 128 pi. I'm not putting the units right now, to 250 pi. And we're eventually going to be talking about areas. I'm just kind of skimming the rest of the question. So I'm going to go ahead and simplify my ratio that I'm given. I know that I can cancel the pi's. If you want to rewrite it as a fraction, if that looks better to you, that's fine. And 128, 250 might reduce. If you want to try reducing those, start dividing. We can divide by 2, probably 4. I'm getting a ratio of 64 to 125 when I go ahead and reduce 128 and 250. So I'm going to keep that as my ratio of volumes. And maybe this time we want to kind of set up our proportions, see what information we have. We've got the smaller cone has a lateral area of 112 inches squared. So I'm going to go ahead and put 112 in one of my ratios. Again, that's an area measurement. You might want to make a little note to yourself if you like to jot down words next to this. Technical difficulties. Pause while I get my pen ready. Okay, that's supposed to be a 2. We're just going to go with it. 112 square inches for the lateral area of the smaller cone. I want to find the lateral area of the larger cone. I'm just using A for my variable. Use whatever letter you want. And I know now that I need a ratio over here, but my ratio needs to be the ratio of areas, since that's what I have on this side. I've got areas. So I'm going to need to fill that in with a ratio of areas. Currently, I only have the ratio of volumes. So I need to do a little bit of work. There's actually not a way to get directly from volume to area ratio. So I'm going to have to go back to my scale factor ratio, and that's what I'm going to do first. Then I'm going to go ahead and figure out my area ratio. So my thinking is, let's go first back to scale factor, and I'm going to do that by taking the cube root of 64 and the cube root of 125. So cube root of 64 and cube root of 125 is going to be my scale factor ratio. Recall that you get the cube root by going to the math button on the graphing calculators. It's the third button on the left-hand row of buttons, and it should be the fourth option there. A little 3 in front of your square root symbol gives you the cube root. So go ahead and do cube root of 64 and cube root of 125. And hopefully you're coming out with a ratio of 4 to 5. So that would be my scale factor measurement. And at this point I can sort of cross that out because that gives me 4 to 5 for my scale factor. So I've got my scale factor, but I really need my ratio of areas. So I'm going to take the 4 and the 5, and I'm going to square them. Ratio of areas should be 16 to 25. Bingo, that's what I needed. That's going to go over here. 16 and 25 is my ratio of areas for two similar solids that have a ratio of volumes 64 to 125. At this point, we are now into the solving stage, and all we need to do is cross multiply and divide. Again, easy part. 16a equal to 112 times 25, which is giving me 2,800. And I'm going to go ahead and divide by 16. My area is coming out to be 175 square inches. For my lateral area is what I was really solving for of the larger cone. Okay, slightly more complex than the first example. Big difference is that in this one we were given volumes. We had to go back to the scale factor before we could get the ratio of areas to then use in our proportion. Okay, I'm going to make one more video, and it's actually going to have two slightly harder problems, so feel free to watch that to help yourself out.